Good afternoon, dear students. In the yesterday's class, we had started with the concept of two-port networks. We had discussed what are two-port networks. We had also discussed what is the significance of two-port networks, or what is the need of two-port networks. Then we had discussed the parameters of two-port network, and one such parameter that we discussed, that was admittance parameters. And with the help of an example, we had seen that how can we represent two-port network in terms of admittance parameters. And yesterday, by taking example, I told you that these two-port networks representation with the help of parameters gives us a tool to follow a black box approach, where we need not worry about the circuit components present in the network under consideration. We are simply concerned with the input port and the output port. So that's the beauty of two-port networks. We are able to visualize our network input and output without worrying about the circuit components. Fine. So in line with previous class, after admittance parameters, next parameter which are important for us, that is known as impedance parameters. Okay. So here comes the impedance parameters. The way we had defined the matrix representation for admittance parameter, in the same way we have introduced Z parameters also. Okay. So your impedance parameters, they are represented with the help of Z, and you all know impedance is represented by Z, and these can be represented through a generalized equation. We know that V is equal to I times Z. So whatever defining equations we have for Z parameters, they are you can say voltage expressed as a sum of you can say I1 Z1 and I2 Z2. So the way we had discussed the representation of Y parameters as superposition of two current components, similarly here we can say that your V1, that is your voltage at the input port, that may be considered as the response produced by two current sources I1 and I2 respectively. So we can see in the network there are two currents which are flowing. One is I1 and another is I2. So obviously your V1 will be equal to responses due to both the currents, that is I1 and I2. So that's why we have written V1 is equal to Z11 I1 plus Z12 I2. Similarly, for V2, this will also be the summation of the responses produced by the two currents present in this two-port network. So that's why V2 is also represented as Z21 I1 plus Z22 I2. Dear students, if you carefully observe these equations are same. The only difference is the Z parameters which has been shown in these two equations. Okay. So these equations can be represented in the form of matrices, as we discussed for admittance parameters also. So it becomes first matrix is column matrix is V1 V2. This is your 2 by 2 Z parameter matrix, that is Z11 Z12 Z21 Z22, and this is your current column matrix. I hope everything is clear once we have discussed admittance parameters in detail. Okay. So now let us move forward. So these Z parameters, they are also called as open circuit impedance parameters. Okay, if you remember in admittance parameters, we had called admittance parameters as short circuit parameters, because there we had made a voltage equal to 0. That means it is nothing but it is equivalent to short. So here in case of impedance parameters, we will be making these I1 and I2 equal to 0. And when current is made 0, our circuit becomes open circuit. That's why these Z parameters, they are also known as open circuit impedance parameters. So all parameters will be open circuit parameters, because they are obtained by open circuiting either input port or your output port. Whereas your admittance parameters were obtained by short circuiting either your input port or your output port. Okay, so now let us see the names of various Z parameters. So first Z11, this is your open circuit input impedance. So students, if you remember yesterday's class, there Y11 was input admittance. So here Z11 is input impedance. Okay, so I hope this thing is clear to all. Similarly, let us take the case of Z22. So Z22 is your output impedance. Okay, and if you remember, Y22 was output admittance. Okay, and yesterday also I hinted that your Z parameters and admittance parameters, they are you can say inverse of each other. Okay, so in fact in the later classes we will talk about the interrelationship between various two port network parameters. So but presently you can assume that your impedance in fact your impedance and admittance, they are inverse of each other. I should not say impedance parameters and your admittance parameters are directly inverse. Okay, so now we are left with Z12 and Z21. If you remember, uh, whenever both the ports are involved, we introduce a term called transfer. Okay, transfer parameters. So in case of Y12 and Y21, we called them transfer admittance, whereas in case of Z12 and Z21, we call them as transfer impedance. Okay, another term that comes here is, because we have Z12 and Z21, so this we call them as reverse and forward transfer impedance respectively. So from 1 to 2, I told you yesterday also, this is called reverse transfer impedance, and from 2 to 1 it is called forward transfer impedance. Fine. So this is all about your impedance parameters. Now as in yesterday's class, we will move to some examples. There we will try to find out Z parameters the way we find impedance parameter, sorry, admittance parameters. Okay, so impedance parameters, the word seems to be a bit longer while speaking these words. So more popular is Z parameters. So Z means impedance parameters. Okay, so now we will solve our numericals and try to understand in a better way. So these are the three numericals, or you can say three networks, for which we have to obtain various Z parameters. And if you remember yesterday, I told you in the two port networks that there will be no independent source present inside this linear network, but dependent source is possible. So I have deliberately taken one example where dependent source is a part of your linear network apart from your input and output port. So see here, this diamond shaped voltage source, it is a dependent voltage source whose value is 0.5 V2, means this voltage source is dependent on this voltage V2. Okay, so in rest of the networks we don't have any dependent source as well, we only have resistances present. Okay, so now one by one we will find out the individual Z parameters for these networks. So for both, in fact all three, A, B and C, we will find out, so that will give you a better idea. Now let us start. Let us start firstly with your network number A. Okay, so our first objective is to find out Z11. Okay, so Z11 is nothing but your input impedance. Okay, means the input impedance when you look from this side into the network. For that you have to make I2 equal to 0. So if you remember, if we represent this in the form of two port network, here we will have I2 directed inside. Okay, and I1 will be directed inside here. at the input port. So let us assume that. Now, since we are taking I2 equal to 0, means there will be no current in 50 ohm resistance. No current means no voltage drop. Okay. So means this resistance is no longer in the picture because it is open circuit. Fine. So we have to, now we are left with this thing only. So if you apply KVL here, so V1 is equal to 20 I1 plus 25 I1 because I2 is 0. Okay. So what do we get? We get V1 equals to 20 plus 25, that is your 45 I1. Okay. And what do we want? We want V1 upon I1. I2 equal to 0 we have already assumed. And we have also taken into consideration the consequences for making I2 equal to 0. So that's why Z11 can be directly written as V1 upon I1, and which is nothing but 45. Obviously it is impedance, so its unit will be ohm. So Z11 is 45 ohm. So I hope this thing is clear to. So students, we have obtained Z11, which has come out to be 45. Now, as I told you yesterday also, we will first obtain Z22 because it is easier to find out Z11 and Z22. Similarly, your Y11 and Y22. In at least personally, I feel so. That's why I'm taking up those parameters. So your Z22, it will be V2 upon I2 and I1 is 0. So I1 0 means this I1 is 0. There will be no drop across 20 ohm, or you can say this input part is open circuit. So that's why this 20 ohm is no longer in the picture. Okay. So what we will have here, we will have this part, this output part in existence. So you can see here V2 is there, I2 is flowing through 50 ohm and 25 ohm resistance. We can apply KVL here. So if we apply KVL, what do we get? V2 is equal to 50 plus 25, that is 75. Okay. And the current which is flowing through this is I2. So in the same way we had obtained Z11 also. Now what will be Z22? V2 upon I2, which is nothing but your 75 ohm. So straightforward. In fact, students, I have taken very simple examples here. You can make these examples very complex also, so that your concepts are clear, so that you are able to understand or visualize these two-port network parameters clearly. That's why these simple examples have been considered here. So this is the way we can obtain Z22. Now let us move to the calculation of Z12. Okay. So let me first erase what we have done here. Okay. So now Z12. So for Z12, you see we need I1, V1 upon I2. Okay. And I1 is made 0. Fine. So I1 is made 0. It means this, there will be no voltage drop here. Is that fine? That means this V1, this will come across this 25 ohm resistance like this. Because there is no voltage drop here. In a way, you can say that this resistance is no longer existing. So this V1 comes here. Fine. We need a relationship between V1 and I2. So if you carefully observe, this I2 is also flowing through this 25 ohm resistance. Okay. Now what is V1? Your V1 is equal to, your resistance is 25 ohm and current flowing through this is I2. So V1 is equal to 25 I2. And what we want? We want Z12, which is nothing but V1 upon I2. So V1 upon I2, that is Z12 is equal to 25. Straightforward and very simple also. This is how we obtain Z12. Now finally, let us calculate Z21. Okay. So in order to obtain Z21, what we want V2 upon I1. We have to make I2 0. Okay. So for I2 0 means this resistance will not be there in the picture. Now the voltage drop across 25 will be V2. Okay. Because there will be no drop across 50, this V2 will come here. And now I1 is flowing in this loop. And this I1 is also flowing through this 25 ohm resistance. So you can see what will be the value of V2? V2 will be I1 into 25. So same thing. So your Z21 will also have the same value of 25. So this is what we get as our final answer for this network number A. Your Z11 is 45, your Z22 is 75, and your Z12 and Z21, these two parameters are your 25 ohm. So this is the simple solution of your network number A. Okay, so I hope students, all things are very clear to you. Now let us move to your network number 2. So students, now we will solve Z parameters for this second network. So let us now find out Z11. So I told you Z11 is nothing but V1 upon I1. I2 is made 0. Okay. So I2 is directed inside at the output port and I1 is directed inside at the input port. So now we have to make I2 equal to 0. I2 0 means there will be no drop across 50 ohm resistance. This circuit is open from the output port side. So that's why 50 ohm is no longer in the circuit. We are having only this much things present in our circuit. Okay. Now, since we need to find out V1 upon I1, this is V1, this is I1, this I1 is passing through these three set of these three resistance. So it means whatever will be the equivalent resistance of these three resistances, that will be our answer for Z11. So let us see this 20 ohm and 25 ohm, these resistances are in parallel. Okay. So 45 ohm, these are in series. So series of this combination is 45 ohm and it is in parallel with 40 ohm. So 45 ohm parallel with 40 ohm. So whatever answer we get here, that will be Z11. And you know the result for parallel combination of resistance, that will be 45 cross 40 divided by 45 plus 40. Okay. And if you solve this, the answer for this will come out to be 21.2 ohm. So this will be your Z11. Okay. Now let us calculate Z22. Fine. So for Z22, what will be the case? So for Z22, we'll have to make I1 equal to 0. Okay. So I1 equal to 0 means there will be no current flowing here. So now it means we are to find out the equivalent resistance for this portion of the network. So your Z22 will be equal to V2 upon I2. So V2 is this one, I2 is going inside. So we have to find equivalent resistance of this. So you look carefully, this 20 ohm and 40 ohm, they are in series. Okay. So we have the total as 60. This 60 ohm is in parallel with this 25 ohm. So we need the parallel combination calculation for 60 and 25. Okay, so whatever answer you get for this 60 ohm parallel with 25 ohm, that is having series connection with 50 ohm. So it will be plus 50. Okay, This is what we get for your Z22, 50 plus parallel combination of 60 and 25. So if you solve this, your Z22 will come out to be your 67.64. Okay, you can cross check these values from your side. So your Z22 will come out like this. Fine. Now let us move forward and we will find out Z12 and Z21. Okay, so first let us see Z12. So your Z12 is V1 upon I2, and we have to make I1 equal to 0. I1 equal to 0 means no current is entering here. So it means, see, we need V1 upon I2. You'll have to basically visualize the circuit. You'll have to basically feel the circuit, that how can you find out these parameters. Only then you will be able to find these parameters in a faster manner. Otherwise, like, you may stuck up with nodal analysis, mesh analysis, KCL, KVL. But if you practice, you could directly come at the solution. Okay, let us see. So since I1 is 0, this V1 will come across this 40 ohm resistance. Okay, now I make out from this circuit that this I2 is entering here. This I2 will divide here. So some part of I2 is going to pass through this 40 ohm resistance, and let that current be I40. Okay, so what will be V1? V1 will be equal to, resistance is how much? 40. Okay, and let the current which is passing through 40 ohm resistance is I40. Fine. So if we can express this I40 in terms of I2, our job is done, because then we will be able to find out the ratio of V1 upon I2. So let us see how will we do that. If you look carefully into the circuit, you'll have to use current divider rule. Your I2 is being divided here. Okay, the two branches are 25 ohm, and the series combination of 40 and 20, that is 60 ohm, means current is dividing into 25 ohm and 60 ohm. So what will be the value of I40? Your I40, you apply current divider rule directly, it will be 25, okay, divided by 25 plus 60, that is 85. Okay, and multiplied with your I2. So your I40 is this one. Now what you do, you substitute the value of I40 in this equation. So if you do that, what do you get? You get V1 is equal to 40 times 25 by 85. So that will be 1000 divided by 85. Okay, into I2. Now you can easily find out V1 by I2, which is nothing but Z12, and the value of Z12 will come out to be 11.76. So for this network, your Z12 will come out to be 11.76. So this is how we obtain Z12. Now let us try Z21. For Z21, what we want? V2 upon I1. Now let us see, V2 upon I1, and I2 is 0. So I2 is 0. This means this I2 is 0. So this resistance will no longer be in picture. This V2, it will appear across this 25 ohm resistance. Okay. So in the way we have calculated Z12, in the same way we will find out Z21. So let us see what will be V2. V2 will be the resistance value, that is 25, and let the current through this 25 ohm resistance is represented by I25. Okay, and what will be I25? I25 will be some component of I1, because I1 is entering into the circuit here and it is getting divided here. So you see, I1 will divide at this node. Again, current divider will prevail. So what will be the value of I25? You apply current divider rule. So it will be 40 divided by 40 plus 45, that is 85. Okay, and into I1. So your I25 is 40 by 85 into I1. So what do? You substitute this value of I25 here and you find out V2 upon I1, that is Z21, and you will get the same value, that is 11.76. So this is how we obtain all the four Z parameters for this network, and I hope you are able to appreciate the calculation of Z parameters and how am I basically applying the concept of circuit analysis directly. I'm simply taking into consideration your KVL or your current divider or your voltage divider, and we are able to come at the solution. And I think this is very, very simple and interesting as well. Okay, now let us move to our example number C. So this is a special case where we have a dependent voltage source. So that way we need to look into this circuit more carefully. Okay, so let us now start with the same methodology, that we will first find out Z11. So Z11 is V1 upon I1 and I2 is 0. I2 is 0 means no current is entering into the uh, circuit. So it means this resistance will be out. So let me represent I1, I2 first. So here we will have I2 directed into the output port, and here we will have I1. Okay. Now the same logic we will apply. Since 50 ohm resistance is no longer in the picture, this V2 voltage will be present across this thing only. Okay, fine. Now since we have to find out Z11, and Z11 is equal to V1 upon I1. Okay, so let us apply KVL in the input loop. Okay, let me rub off this thing so that there is no confusion. So it is now more clear. We have to apply KVL in this loop. So if we do that, what do we get? We get V1 is equal to I1 is entering. So since there is no current here, so your I1 will not go here. It is open circuit. So 20 and 25 ohm in series. So what do we get? V1 is equal to 45 into I1. Okay. So 45 into I1 plus, this is dependent voltage source, but it is a voltage source, so obviously we'll have to write its value. Its value is 0.5 V2. So we'll write 0.5 V2. This is what we have written. Okay. Now what next? Next thing is we need to find out the value of V1 upon I1 given I2 equal to 0. So we have taken into consideration the consequence of I2, that is 50 ohm resistance will not have any drop. This V2 will come here. Now we will be able to find out Z11 only when this term is not there. So we'll have to eliminate this term. So in order to eliminate this term, we need to substitute something for V2. So we have this outcome here, that this V2 is the voltage across this. Okay, and now through this 25 ohm resistance only I1 is flowing. So what will be V2? Your V2 will be equal to, now apply KVL here. V2 will be equal to 25 I1, 25 I1 plus 0.5 V2. This is what we have already discussed. And if you solve this, if you take 0.5 V2 towards left hand side, it will become again 0.5 V2. So 0.5 V2 is nothing but 25 I1. So instead of this 0.5 V2, you can write 25 I1. So what do we get? V1 is equal to 65 I1, and we want V1 upon I1. So what does it mean? Z11 will be how much? 65. That's it. Very simple. So this circuit seemed a bit complex, but I think I made some small calculation mistake. 45 plus 25 is not 65. 45 plus 25 is 70. Okay. So Z11 is not 65, it is 70. So your answer for Z11 comes out to be 70. I hope this thing is clear. Now let us move forward. Now we will find out Z22. So for Z22, we have to make I1 0. Okay. And we have to find out V2 upon I2. So what we do, I1 0, that means this resistance will no longer be in the picture. We need V2 upon I2. So now we will write equation for V2. So for V2, it will be apply KVL in this loop. Okay. So V2 will be 75 I2 okay, plus 0.5 V2. Okay. So here we have made I1 equal to 0, and this V2 is equal to 25 I2, sorry, 75 I2 plus 0.5 V2. Okay. So now we don't need any other equation. We have this equation in V2 as well as I2. So you take this V2 towards left hand side, this becomes 0.5 V2 equal to 75 I2. So what do we have now? V2 upon I2 is equal to 75 divided by 0.5. And if you solve this, your V2 upon I2, that is your Z22, it becomes 150. I hope this thing is clear to you. So your Z22 is nothing but its value is calculated as 150 ohm. Is it fine? So this is our second answer. Now let us calculate Z12 and Z21. So that thing is also very simple. So students, if you remember circuit concept, if you are comfortable with your circuit analysis techniques, then it is very interesting and you can say a child's job to solve these simple networks. Now we have to calculate Z12. So for Z12, we'll have to make I1 0. I1 0 means this resistance will be out. We need ratio of V1 and I2. So first let us write equation for V1. So V1 will appear across this R. Let us write equation for this KVL equation. Your V1 is equal to, now in this 25 ohm, I2 is flowing. So that's why V1 is equal to 25 I2 plus 0.5 V2. Okay, 0.5 V2. This is our V1. And we need ratio of V1 and I2. So we need to eliminate V2. How can we eliminate V2? We will have to write again equation for V2, KVL equation. So your V2 will come out to be how much? As we had written earlier also, V2 will be 75 I2 okay plus 0.5 V2, and from here you can find out the value of 0.5 V2. 0.5 V2 is nothing but 75 I2. You put 75 I2 here. So what do you get? V1 equal to 100 I2. 100 I2. And ultimately we want V1 upon I2. So your V1 upon I2 is found to be 100. So your Z12, the value of Z12 is 100, that is 100. Now let us hurriedly calculate Z21. I think you can also verbally calculate this Z21 now. So your Z21 is nothing but V2 upon I1, this one. V2 upon I1. So what we want for this, I2 equal to 0, means this arm is out of the picture. So we need equation for V2. Let us write V2 will appear across this arm. Okay. So your V2 is equal to, current through 25 ohm is I1. So 25 I1 plus 0.5 V2. So just by this equation only we will be able to find out the final answer. So 0.5 goes towards left hand side, it becomes 0.5 V2, and V2 upon I1 is nothing but 20 by 0.5, that is 50. So your V2 upon I1 is equal to 50, and V2 upon I1 is nothing but your Z21. So your answer comes out to be 50. So this is how we find out Z parameters for the networks. Okay, I hope everybody is pretty clear of all the three numericals. If there is any difficulty, you can discuss with me, but I hope everything is clear to everybody. So dear students, with these three examples, our discussion on Z parameters is over. And in the next slide, I had shown you the answers also, but since I have already covered that, so till now we have covered admittance parameters and Z parameters, and in fact these two parameters, whether it is your impedance parameters or admittance parameter, we are already aware of these terms. And next parameters are known as hybrid parameters, that is H parameters. You may not have heard of that term. So, and in fact out of all the four parameters that we will be studying, or we have studied, H parameter is the most important one. So we will discuss about these H parameters in the next class. I stop here, and I basically appeal you students to practice a lot related to the solution of these Z parameters and Y parameters. You can take any book which is available on internet or available with you also, and then you can solve numericals from that. So unless you practice, you will not be comfortable with the solution of the numericals. So students, I stop here, and we will continue in the next